exponents. So for all of these, we are going to express our answers in radical form. So if you have a radical expression, you know it's in the simplest form when all three of these things are true. So the radicand has to contain no factors that are powers of the index. The radicand contains no fractions, and no radicals are appearing in the denominator. That's where we'll have to rationalize, but you guys did that back in geometry. So let's start with number one here. So for number one here, we are taking 64x to the 12th power, all raised to the 5th power. So when we're simplifying square roots or cube roots, we can kind of skip this first step. But since we are taking a 5th root, I think it is necessary that we look at prime factorization. So let's take 64 and let's start to factor it. So my first factor, I'm going to take 8 times 8. Then I can split 8 as 2 times 4. And I'll split 4 as 2 times 2. And I will do the same on the other side. So prime factorization tells me that 64 is the same as taking all of these 2's and multiplying them together. So I have 6 total 2's. So I can rewrite 64 as 2 to the 6th power times x to the 12th power. So now if I want to simplify my radical, I'm going to want 5th powers, right? Because that is what a 5th root undoes. So I'm going to rewrite 2 to the 6th as 2 to the 5th power times 2 to the 1st power. That's the same thing as saying 2 to the 6th power. And then my x to the 12th power, I'm just going to rewrite this as x to the 5th power times x to the 5th power, because both of those will simplify with my 5th root. Right now, I have 10 powers of x. I still need 2 more, so I have x squared on the end. Now I'm going to go ahead and simplify. So all of my 5th powers are going to simplify, and the rest are going to stay as a radical. So this becomes 2 times x times x times the 5th root. I have a 2 left over, and I have x squared left over. And then finally, I'm just going to simplify my coefficient out here. I've got x times x, which I'm going to make that x squared. So I have 2x squared times the 5th root of 2x squared. And that's going to be my final answer for that one. Okay? So we're just going to kind of repeat the process with a couple of different examples because there is a variety of different scenarios that we're going to see. So for number 2 here, we don't have a radical explicitly written, yet remember, anytime you have fractions in your exponents, that implies that we're working with radicals. So for this one, we're going to take our coefficients and our variables and let's combine them. So I can rewrite this as 2 times 3. Now we've got x to the 1/2 times x to the 1/4. Okay, I'm just going to multiply my coefficients. So 2 times 3, that's going to give me 6. I'm going to multiply my variables here. Yet remember, when you're multiplying like bases, you have to add your exponents. So in order to add exponents, or in order to add fractions, we need to have a like denominator. So 1/2, I'm going to multiply my numerator and denominator by 2 to get the like denominator. So I'm going to rewrite 1/2 as 2/4, and I've still got 1/4. add those two exponents together. That's going to give me 6x. 2 plus 1 is 3. 3/4. Okay, like we said above, all of our final answers are going to be in radical form. So I'm going to rewrite this as a radical. So I've got 6. A 4 in the denominator means that I'm taking the 4th root, x to my numerator, which is 3. All right, let's do a couple more examples here. So going down to number 4, let's go ahead and simplify this. So first of all, with my 4, I can't simplify that in any way to simplify with a 5th root, so I'm just going to leave it. Okay, I'm going to split x so it simplifies. So if I make x to the 5th power, in order to get to 8th powers, I only have 3 left over. Y to the 14th. So if I make it y to the 5th, I still have 9 left over, so I can have another y to the 5th. This gives me y to the 10th power. And I have y to the 4th left over. Not 9, we'll make that a 4. And then finally, with my z, I've got z to the 5th, which is perfect because that's going to simplify. So simplifying this, nothing I can do with my 4th power. This x to the 5th is going to simplify. This y to the 5th is going to simplify. The other y to the 5th is going to simplify. And z to the 5th is going to simplify. And left under the radical, I'm going to have 4 x to the 3rd and y to the 4th. Okay, nothing I can do underneath my radical at this point. I can simplify what I have outside. Y times y, I'm going to make that y squared. So I've got 2x, I've got x, y to the 2nd, z times the 5th root of 4x cubed, y to the 4th. All right. So number 5 here. In number 5, we can split our radical into 2 separate parts. So I can rewrite this as the 5th root of 7 over the 5th root of 8. So this is one of those scenarios where, as of now, there's really nothing we can do to simplify this. Yet we do need to rationalize our denominator so that we don't have any radicals in the denominator of our fraction. So the first thing I'm going to do is prime factorize 8. 8 is just going to give us 4 and 2, 4, 2 and 2. So the simplest I can make this is 2 to the 3rd power. So let's rewrite it as that for now. We're not going to worry about our 7 since it's in our numerator. 5th root of 2, and we have 3 of them. Okay. Obviously, 2 to the 3rd cannot simplify under a 5th root. So let's multiply it by something that can. So let's rationalize by multiplying our denominator by 2 squared. This way, I would get 2 to the 5th power in my denominator. And I must also multiply that by our numerator. So let's go ahead and simplify. So first of all, simplifying my numerator, 7 times 2 squared underneath the radical. 2 squared is just 4. So 7 times 4 is 28. So I'm going to make that the 5th root of 28 over, and then I'm just going to multiply my exponents. So the 5th root of 2 to the 5th power. Okay, I'm going to go ahead and simplify. The 5th root of 28, there's nothing I can do there. Over 2 to the 5th power, well, the 5th root of 2 to the 5th power is just going to give me 2. So that way, I have rationalized my denominator. Okay? Very similar process here with number 7. So right now, I have a cube root in my denominator. I think we could see this right away, though, because this is 2 to the 1st power. I need 2 to the 3rd power to be able to simplify. So to rationalize, let's multiply it by the cube root of 2 squared, and let's simplify. So in my denominator here, that's going to become the cube root of 2 to the 3rd power. And then on top, I have 6 times 2 squared. So I have 6 times 4. Well, actually, let's just leave it like that. So I have 6 times the cube root of 4, which there's nothing I can do to simplify that, which is nice. So all I need to do now is simplify my denominator. The cube root of 2 cubed is just going to give me 2. So I've got 6 times the cube root of 4 all over 2. I'm going to simplify my fraction. 6 divided by 2 is going to give me 3 times the cube root of 4. Nice. All right, so last example here, number 8. We'll save the right side for class. Once again, I need to rationalize my denominator here. So I'm going to multiply this. I have a square root right now. So thinking about each of my terms individually, 3, in order to make this a perfect cube, I could just multiply this by 3. So I'm going to multiply 3 by 3, which will give me 9, which can simplify. Right now I have x. I'm going to have to get that to x squared. So all I need to multiply is x. And right now I have y cubed. I need to get that to y to the 4th. So I'll also multiply that just by y. Okay, I'm looking for even powers since I'm taking the square root. So in my numerator here, I'll just take 12 times 3xy. And in my denominator, I'm going to get the square root. 3 times 3, which is 9. X times x, which is x squared. Y cubed times y, which is y to the 4th. Okay, I'm going to go ahead and simplify. So I've got 12 times the square root of 3xy over the square root of 9, which is 3, the square root of x squared, which is x, and the square root of y to the 4th, which is y squared. And now I'm just going to simplify my constants. 12 over 3 gives me 4. So I've got 4 times the cube root of 3xy all over xy squared. And that right there is my simplest form. So I know we went through a ton of examples in this video. Please make sure to go through all of the right side on your own, and we will check them together in class. So we just have 1 or 2 more things to go over. I know this video is going to get a bit long, but let's take a look at number 10 here. So all we need to do is simplify this. We need to assume that all of our variables are going to be positive. So in my first example here, I have xy to the negative 1/8 power. So I need to take care of my negative exponent. This exponent is only going on y. So really, this is just x to the 1st power. So to simplify this, x to the 1st, nothing's going to change. But in order to make this a positive exponent, let's take the reciprocal. So I have y 1 over y to the 1/8 power. Okay, let's rewrite y as a radical here. So I have x over the 8th root of y. I can rewrite that. Okay? If I want to simplify y in this case, I'm going to need to make this y to the 8th power. So in order to rationalize, let's multiply this by the 8th root of y. Right now I have y to the first, so I'm going to need 7 more. Okay? I don't know why I wrote that so big, but oh well. So I have x times the 8th root of y to the 7th. Nothing I can do there. Over y to the first times y to the 7th. This gives me the 8th root of y to the 8th power. Which is going to simplify as just y over x times the 8th root of y to the 7th power. Okay, let's just do one more down below here. So in this case, I have the cube root of 7 times the cube root of 49. So I'm going to turn these all into powers of 7 to see if we can make this simplify. So obviously, we got 7 to the first power there. But I'm going to simplify 49 as, I'm still stuck on y's, 7 squared. Okay, so if we're multiplying these together, they do have like bases. So I can simplify this as the cube root of 7 to the 3rd power, which these are just going to cancel, leaving me with just 7 in this case. Okay, final section here, like radicals. So we've already talked about this. If two expressions have the same index and radicand, so the same radical, you can add or subtract these because they are like terms. So in number 16 here, we can't simplify anything as of now because our two radicals are different. Yet we can simplify our second radical so that we can subtract. So let's prime factorize 45 here to see how we can simplify this. Okay, so I'm going to split 45 into 9 times 5. 5's a prime number, nothing we can do. And then I'm going to split 9 as 3 times 3. So I've got 5 times the square root of 5 minus the square root of 3 squared times 5. Okay, I can factor it just like that. 3 squared can simplify. So I've got 5 to the square root of 5. 3 squared, just going to give me 3 times the square root of 5. So now at this point, my radicals are the same, so I can subtract these. 5 minus 3 gives me 2, and then I've got my square root of 5 taken along on the end. So we've already done like radicals. This first example here, number 16, you may have been able to do it in your head, which would be just fine as well. All right, please copy down the other examples. We will go through as many as we need in class together, but hopefully this gave you guys a good start into 6.2. All right, thanks for watching.